Graphing is an important way to show the data that was collected in an experiment, especially when the experiment was redone a number of times. It gives a pictorial view of what you discovered. A graph can consist of many parts, so that it will be easy to understand. Can you think of any that you would need other than the ones mentioned here? The title. This is what I'll look for first. It tells me if that graph is what I am looking for. Does it contain the information I am looking for? It should be a concise statement placed above the graph. Next, there are the variables. What are they? Oh, yes. They do describe what is being measured. But how many are there in the experiment, and how many do I need to show in the graph? And where do I put them? The first is the variable that I was in control of. Was it time in days, minutes, hours, weeks, months, or years? Was it length, depth, or width in inches, centimeters, feet, meters? Or was it temperature, degrees Celsius, or Kelvin? How can you control time or temperature? They just are. I cannot physically change them. But I do decide when to check them, and that is what makes them a changeable variable. This variable is always placed on the x-axis, the horizontal axis. Then there is what changed in the experiment when I changed that variable. It is what was directly affected by the independent variable. It is the result of what happens and was recorded. It could be growth, the formation of gases, a color change, or the formation of a solid in a liquid. It is any observed change that occurs, all being the result of what I did. This, the dependent variable, is always placed on the y-axis, the vertical axis. Now, how did I measure the units of the variables that I used? By themselves, the variables simply say what I was using. It does not tell how I used them. So I must also include the units used for each variable. Otherwise, my measurements mean nothing. Units describe how the variable is being measured. For example, distance could have been measured in centimeters, inches, feet, meters, miles, kilometers, etc. Temperature could have been in Fahrenheit, Celsius, or Kelvin. And each gives a different value for what was measured. The next important part is to place equal scales for each variable used. For the graph to be readable, all of the data must be placed on the graph, and the spaces between the measurement needs to be the same across each of the axes. You do need to know where to plot the points representing the data. The scales should always start with 0 unless all the data starts at a larger number. They should then climb based on intervals such as multiples of 2, 5, 10, 20, 25, 50, or 100. Intervals must remain the same on an individual axis. However, the intervals on different axes do not have to be the same. The interval you choose will be from the data collected and should have been put into a readable table. Pick an interval that uses the entire graph, so it is large and easy to read. Your scale is also labeled with the appropriate units. Legends, sometimes referred to as keys, should be easy to read and put somewhere within the graph, or in a bottom or top header position. When recording more than one set of data, it is best to use different colors to represent the data of each set. But you can also use different types of symbols, such as a circle, square, or triangle for the different sets of data points. You can also use a solid or broken line to connect each set of different data points. When setting up the graph, first put the title. Next, figure how many data points need to be included in each axis. Then draw out the X and Y axis. Make sure there is room for labeling each with both the units and variable's name. Now write the independent variable and units under the X-axis. Then do the same for the dependent variable on the Y-axis. Examples of the independent variable would be time and the units, seconds, minutes, hours, days, etc., or depth with the units inches, feet, yards, etc., or temperature with the degrees in F or C, or maybe it would be KT. Next, set up the scale measurements with 0 with increases at intervals of 0, 2, 4, 6, or 0, 5, 10, 15, etc. Then you finally put in the legend, which acts as a key for what is being graphed.